Today we will be subtracting decimals using the standard algorithm. Okay, let's review a little bit. Can we subtract these two fractions as they are? 3/10 minus 27 hundredths? No, we can't subtract them like they are, but what do we need to do so that we can subtract them? We need a common denominator, okay? 3/10 is the same as what value that has the same denominator as 100? Well, if I multiply by 10, multiply by 10, then I'd end up getting 30 over 100. Can I do 30 hundredths minus 27 hundredths? Yes, I can. Now that they have the same denominator, I can definitely subtract them. And we end up with an answer of 3 hundredths. Our objective for today is to subtract decimals using the standard algorithm. When would you need to subtract decimals in the real world? Well, the one that everyone thinks of is always money. If I have, let's say, a $20 bill and I go to a store and I buy something and it costs me $2.27, I need to be able to do some subtraction to understand how much I should get back from the cashier when they make my change. Okay? Or let's say I'm even a cashier. I'd want to know how much change to give, right? So we use it all the time, and money is just one example of something that we use decimals and subtracting decimals in the real world. Okay, so let's review a little bit. Use the chart below to subtract by drawing discs. We did this the other day. 3 17 hundredths minus 2 3/10. Well, here's my 3 1/10 and 7 hundredths, and we're going to subtract 2 3/10 just by crossing them off. We had no hundredths to subtract. Here, to subtract 3/10, I can't do that from 1/10, so I'm going to regroup and take one whole away. One whole, or 1 gives me 10/10. Now I can subtract 3/10, getting 8/10. And now my 2 1s minus my 2 1s gives me 0. I don't have any 1s in that column. So my answer to this problem ends up being 87 hundredths. Let's go to our notes. Use the chart below to subtract by using the standard algorithm. How many ones are in 3 17 hundredths? Well, there are 3. The big difference with what we're doing right now is we're just writing the number instead of drawing discs. That's the biggest difference. So I have 3 in the ones column. How many tenths are in 3 17 hundredths? Well, I have 1. Notice it here. How many hundredths are in 3 17 hundredths? Well, there's a 7 in the hundredths place, so I can write it there. Okay, how many ones are in 2 3/10? 2. Notice I'm writing the 2 in the ones column. How many tenths are in 2 3/10? Well, there are 3. How many hundredths are in 2 3/10? Well, there aren't any. If there were any, it would be a 0. I like putting zeros because that way I have a digit for every digit in my original number. Okay, so let's go ahead and subtract. Remember, with subtraction, you always start with the place value furthest to the right, meaning the place value that has the least value. Okay, so we have 7 minus 0, giving us 7. 1 minus 3, oh, that can't be. We must subtract by regrouping. So we're going to regroup from that 3 and take one of those ones away, giving it over here, making that 3 change to a 2. And when I take away 1, 1, that's equal to 10, 10. So that 1 now becomes 11. 11 minus 3 gives me 8. 2 minus 2 gives me 0. And we come up with the same answer we did on the last problem, but this time instead of discs, we use the actual digits to represent the numbers. 87 hundredths was our difference for this problem. Okay, let's go ahead and do another problem. Use this chart below to subtract by using the standard algorithm. 6 3/10 minus 4 72 hundredths. How many ones are in 6 3/10? Well, there are 6. How many tenths are in 6 3/10? There are, look at the tenths place, there are 3. How many hundredths are in 6 3/10? Well, there aren't any hundredths, but I notice in my second number there are. So it's going to be valuable for me to put a 0 there as a placeholder or an annex 0. Okay, we'll get to that in a second. How many ones are in 4 72 hundredths? Well, there are 4. Let's look at the ones place, which is right in front of the decimal point. How many tenths are in 4 72 hundredths? Let's see, the tenths place is right behind the decimal point, so that would be 7. And how many hundredths are in 4 72 hundredths? There's a 2 in the hundredths place, so let's put a 2 there. Okay, now here's where that thing that I said was important. 2 subtracted from nothing. Well, if I have nothing, I can't give you 2 of anything. So we're going to have to regroup. In the meantime, it's important for us to put that annex 0, a number or a digit, in each place value that the other digits are. Okay, so would I end up with 2 hundredths after I find the difference? No. If I take 2 away from nothing, I can't give you 2 M&Ms if I don't have any to start off with. So we need something to start off with, and we're going to need to borrow or regroup. Okay, so we're going to take away from 3/10. We're taking 1/10 away. 1/10 is equal to 10 hundredths. So we took 1 away, that became a 2. Now we have to give 10 hundredths over here. 10 minus 2 gives us 8. 2 minus 7, oh, we can't do that either. So now we have to regroup again, going to the next highest place value, which is the ones place. That 6 is going to change into a 5. And we're going to give 1 1 to the tenths, meaning giving 10 tenths. And we have 2 here, so 10 plus 2 is going to give me a total of 12 tenths. 12 tenths minus 7 tenths is going to give me 5 tenths. 5 ones minus 4 ones gives me 1 1. So my final answer is 1 58 hundredths. 1 58 hundredths. Here we see that we had to put a 0 in the hundredths place so that we would know to regroup. Okay, it's very important that we have a number above and below each other digit. On your whiteboard or in your graphic organizers, let's go ahead and try this problem. We have 97 hundredths minus 8 hundredths. Pause the video. Okay, so if you did your work, you would end up with 89 hundredths. We had to borrow or regroup to make that 7 into 17 because we can't do 7 minus 8. So we had to regroup there and ended up with 89 hundredths. Okay, how could you solve this problem? Well, where's the decimal point on the number 13? It's right after the 3. Anytime we don't see a decimal point, there's an invisible one, like a period at the end of a sentence, right after the last number we see. Okay, so, whoops. So let's go ahead and solve this problem. 13 minus 5 6 hundredths. Don't forget, we want annex zeros above each digit so that way we can make sure that we regroup when necessary. Okay, here we go. We had 13 here. We had to regroup because we had zeros up here, getting a final answer of 7 94 hundredths. If you didn't have a place value chart, what could you do to subtract decimals and make sure you are only subtracting numbers in the same place value? Well, 1, you stack the numbers vertically, and 2, you line up that decimal point. Once the decimal point is lined up, you're making sure that all the place values are lined up too. You can only subtract numbers that are in the same place value. If I come over here, back to our last problem, I can only subtract 5 from the ones place. I can regroup and borrow, but I cannot subtract the 5 from the 1 here. I can't subtract the 6 from the 3. I need to line up those decimal points so that I'm only subtracting numbers in the same place value. Just like addition, we should only be adding numbers from the same place value. All right, so let's use the standard algorithm to subtract 22 and 42 hundredths minus 13 and 9 tenths. First things first, did we set this up correctly? No, I just said we need to line up those decimal points. So let's move everything over so that those decimal points are in line. The 9 is a tenth. It's 9 tenths. The 4 is 4 tenths. We need those to be on top of each other. These are 2 ones and 3 ones. They need to be lined up. 2 tens and 1 10. They need to be lined up. Okay, so we always line up our place values by lining up our decimal points. Okay, let's go ahead and put a 0 there. Let's make sure that we have the same number of digits behind the decimal and draw an annex 0 so that way it makes our math a lot easier to do and visualize. 2 minus 0 is 2. 4 minus 9 we can't do, so we have to regroup. That 2 becomes a 1, and that 4 becomes a 14. 14 minus 9 gives us 5. 1 minus 3, we can't do that, so we need to regroup again. The 2 in the tens place becomes 1. The 1 in the ones place becomes 11. 11 minus 3 gives us 8. And 1 minus 1 gives us nothing. So we end up with 8 and 52 hundredths as our final answer, the difference between these two numbers. How could I check to see if I got the right answer? Well, subtraction and addition are inverse operations, so we could always take our difference and add it to this 13 and 9 tenths, and if we did our math correctly, we would end up with this 22 and 42 hundredths. Okay, so one way to add, we line up that decimal, and we get our 22 and 42 hundredths. Our answer of 8 and 52 hundredths, this is still our answer, is correct because we checked our work. Go ahead and on your whiteboard, don't forget to line up your decimal. Use the standard algorithm to subtract 24 and 8 tenths minus 5 and 31 hundredths. Pause the video. Here we go. Our final answer is 19 and 49 hundredths. 19 and 49 hundredths. How can we check our answer? We could add 19 and 49 hundredths with 5 and 31 hundredths and hope to get 24 and 8 tenths. And when we add these two numbers together, we in fact get our desired answer. Okay, what is important to remember about subtracting decimals? To line up the decimal and to put a 0 under every or over every digit after the decimal point. How does this help subtract the same place values? By lining up the decimal point, we're lining up the place values. It's like we're creating a place value chart, but we don't have to do all of that work. All right, last problem. On your whiteboard, go ahead and subtract 15 and 72 hundredths minus 3 and 45 hundredths. Pause the video. Line up that decimal. 2 minus 5, we can't do that, so this 7 becomes a 6. This 2 became a 12. 12 minus 5 is 7. 6 minus 4 is 2. Ooh, bring down that decimal point. 5 minus 3 is 2, and 1 minus nothing is 1. So we get 12 and 27 hundredths. Thanks, guys.